Okay, take a look at designing maps. There's a series of lectures to relate to Chloropleth maps, colors, displays, queries, scales and thresholds, hyperlinks, and tips for maps. Chloropleth means color-coded polygons. So we have vector polygons on our maps, and what we're going to do is to relate the information that is stored in the attribute table in terms of color, monochromatic or saturated in nature, and they will represent some numeric value. So in other words, the population or the number of housing units or percentage of vacancies and so on, for examples. So here's the percentage of vacant housing units by county, and the idea here is that a Chloropleth map will allow to convey some information. And what you're trying to do is tell a story with this map. And so the story here is, where are there large percentages of vacant homes? And you can see your eye is just naturally drawn to particular areas that are dark in color. Your eye kind of moves over this very quickly, but it gets drawn to the darker area, which is what we're trying to convey. We're trying to convey that there are certain locations in the United States that have got very high percentage of vacant housing. So classification is a means by which we take the attribute table data and we cut it into groups called classes or bins, and then those are certain similar characteristics. For example, here, vacant units, if there is 2 to 9% vacancy, that'll be colored yellow. Yellow is kind of a calm, non-aggressive color, if you will. But as you go to the higher numbers, you get this very dark blue. So even if you look at this scale of colors, your eye is naturally drawn down here to the bolder color at the bottom. So we divide or classify the housing units into points where we take a break at different levels. And you can see here this is about 10% different, and down here it's about 30% different. So it really doesn't have to be uniform and so on. In fact, that's one of the things that we do, is we play with how these are broken down so that it conveys the information we're interested in. So you want to keep that relatively small so that it's not too confusing, and you want to use some sort of mathematical method instead of just picking arbitrary values. So janks, or natural breaks, are picked out by the computer. It analyzes the data and it says, okay, it looks like there's some good groups here, and tries to get the groups together and also tries to separate the differences between the classes. So when you do this, you find that you do have some large jumps, and the classes are not even, and it's some sort of subjective thing as to how you want to put these together. What you have to be very careful about, and this is a real important aspect, is that if you choose certain breakpoints in one map and you want to compare that to another map, you really must use the same breakpoints. Otherwise, the information could look the same when it's not, or it could look terrible when it really is not terrible. So we have to be very careful when you're comparing one map with another one that you use the same classification methodology. So quantiles. So what you do is you add up, if you have 100 points of data, then you would divide that into the number of classes. If you had 4 classes, there would be 25 data points in each one. Works very nicely with that is that your maps look pretty good, because you have a situation where the same number of yellow colors that you will as green, and so on and so forth. So you get a very nice color distribution on your map. So for example, if you're doing it based on percentages, these are all evenly broken down. So equal intervals takes the data and divides it into groups with a range that's equal in each one. And so it doesn't show up very well that are kind of clustered. In other words, we have a lot of data down here at the bottom and a lot of data up here at the top and not much in the middle. What will end up happening is we'll end up with a lot of colors down here and a lot of color at the other end. So we may have 7 different colors, but most of the map is an extreme one color or the other. So that makes for a difficult information communication, I guess. So exponentially, what you can do is have increasing intervals. In other words, you start out close to 0 and your intervals are close together, and then as you get larger or further away from 0, the intervals are much larger. So here we have 0 to 1, and you got 1, 2, and then here 5, 8, and 9, 16, so on. So the intervals get larger as you move away. Increasing widths are good for what's called long-tail distribution, which means that a lot of the data is down here at the bottom, but then it stretches a long way and to the right. So that deviates from a bell-shaped curve, so it's handling these curves that have a long tail or a left-hand tail, either way. So you could keep doubling the interval. So 0 to 5, next interval's 10, next interval's 20, next interval's 40, and so on. Okay, so now to take a look at this in terms of some examples. This is the population by states. And so if we look at this map, it very clearly shows us that California is number 1. But we don't get much differentiation here between, Texas, New York, Ohio. It just doesn't. We don't know how these states compare to one another. And the other thing over here, we have all these low states where we say, okay, the population is low in these states, but we don't know, for example, how they compare to each other, like North and South Dakota. How do they compare? We don't get that information. So this may not be the best representation. Here if we did equal interval, and over here's our breakpoints. You always want to put this on your map so people can see the legend. And here you're going from 400,000 to 7 million, and that's a 7 million step as you go down through. Now we have obviously California is number 1, and Texas is number 2, and New York is 3, and then it drops down to these other states. So we do have a good distribution of what's happening at the top end. We can identify the highest 4, for example. We get no information about what's happening in these other states with respect to their population comparisons. Okay, so the quantile scale here, so now you can see we're going from 4 to 1.2 million. In fact, to get to 7 million, we have to go all the way down here to one of the later colors. So now we're getting a pretty good distribution and pretty good idea of how population compares in the lower end states. However, all of the upper end states are all the same color, so we don't get any information with respect to, say, New York and Pennsylvania look the same, for example. So now we've got an exponential display, and so we start out 0 to 2 million on the low end, and then we increase these. So this is a factor of 2, this is 4, this is 8, and so on. So now when we do it in this fashion, you can see we've identified the 3 top states, and we've shown that these other states here are kind of second class, if you will, and we can see that in the underpopulated areas we've got at least some idea of how the population is scattered.